So what I plan to talk about are first a bit of biography, a bit about the discovery of pulsars, pulsating radio stars, a bit about the role of women in Britain then and now, and a bit of advice, which you may not need, may not want, about how to keep in the field if that's what you want to do. So I am originally from Ireland, from the north of Ireland, the British bit, and I attended the local school to begin with. I failed an important exam at age 11. At that time, it was believed that you could judge whether a student was going to be academic or not academic by age 11. And everybody in Britain had to take an exam then to see if they were going to be academic or not academic. And they had very different school experience after that exam, depending on whether they had passed or failed. And I failed, so I should have been a non-academic. I subsequently learned that because at age 11 or 12, girls have matured more than boys, a lot of girls were passing that exam and keeping boys out of the academic stream. And to be fair to the boys, they had a higher pass mark for girls. Anyway, it had always been my parents' plan that at age 13, I would go away to boarding school to broaden my experience. And they insisted that I went into the academic stream, which was great. I enjoyed that, except that the boys went to the science laboratory and the girls went to the cookery and sewing room. Girls could not learn science. Girls did not need science. Girls were only going to get married and be stay-at-home mothers and wives. So they needed to know how to cook and to sew. They did not need an academic education. Well, I wanted to do science. And when I told my parents that evening what had happened, they were very, very cross. And they telephoned the head teacher. And the next time the science class met, there were all the boys and 3 girls. Wow. We were the first girls to do science in that school. We did physics the first term, and I loved it. And I came top in the exam. I got 99%. The thing I got wrong was the speed of light. And there's a lesson here. So I will tell you about the speed of light. We learnt about the speed of light in old British units, but it would be much the same for you. So question, what is the speed of light? And I wrote it down in miles per second. And I wrote down the right answer, the correct answer. Then for the first time in my life, I looked at that number and thought, that's very big, and changed miles per second into miles per hour and lost a mark. It is a very good idea to look at your answer. Is it sensible? Is it crazy? Just do not do that for the first time in an exam. Do it before the exam, please. Anyway, I very much liked the being in the senior school, getting to do science, learning languages, lots of things. Then at age 13, I went away to boarding school in England, and I continued good at physics, and I studied maths and physics right through the school. I had decided that I would do a physics degree at university, and then I hoped to go on and do a PhD in radio astronomy. So I went to the University of Glasgow, this is it, to do a physics degree. Not many women did physics at university there and then. The honours class had 50 people, 49 men and me. And it was the tradition that at that time, when a woman entered the lecture theatre, everybody whistled and stamped and banged the desk and made as much noise as they could. It was very embarrassing. And the women used to wait outside the lecture hall and go in a group. But because I was the only woman, I had to go in on my own. Anyway, I did my physics degree. I got my bachelor's degree in physics, and I still wanted to do radio astronomy. There's a very famous observatory in England called Jodrell Bank, and that's where I wanted to do my PhD. But when I wrote to them, they never replied. And I had been told that they probably would not take any women. So I thought, this is why they are not replying. They are not taking any women. I learnt afterwards that the professor in charge of the applications did not think it was necessary to reply. He would tell us what the decision was when he had decided, but until then he did not write. They're better at it now than they were then. So I gave up on Jodrell Bank. I thought I am going to have to go to Australia to do this PhD because I will never get into Cambridge. I'm not clever enough. But as probably is the case with you, the academic year in Australia begins in January or February, not in October. And so I had a few months in hand. And I thought I should put in an application to Cambridge just in case they accept me. And I did, and very much to my surprise, they accepted me. So I went from Glasgow to Cambridge. I have found quite often that particularly in Glasgow, when I was the only woman in the honours physics class, other women would say to me, "Are you sure you want to do physics? How can you bear to do physics? How can you bear being the only woman in the class? Are you sure?" So it was women who were deciding what was okay for women. The men did not care so much. But it is the men who decided whether I got a place or not, of course. So this is a photograph of the telescope at Jodrell Bank with the setting sun. It's quite an old telescope now. It is a World Heritage Site. And it's been doing radio astronomy for about 70 years now. So it's got a long history. When I arrived in Cambridge to do my PhD, all the radio astronomy graduate students got given a set of tools. These are my set of tools. These are not microelectronics tools. These are full-size tools. These are for wire working. and we did a lot of quite heavy physical work. I joined a project that was to find quasars. Quasars were very, very new, quasi-stellar radio sources. There were only about 20 known. It was known by then that they were very distant and therefore extremely bright. But what they were was not known. They were primarily radio astronomy objects. The optical astronomers would say that they're a peculiar sort of star thing on the photographs. So they didn't really know what they were until Martin Schmidt in Caltech, realized that the spectrum of the quasar he was looking at was a hydrogen spectrum with a large redshift. So these things were very bright, but also very distant. So extremely bright and a huge puzzle. So my project was to identify more quasars and to attempt to measure their angular diameter in the radio. I'm not going to go into the details of the technique I used unless people want to ask about it afterwards, but quasars twinkled in the radio, they scintillated. And to observe the scintillation, you had to use a short time constant, a short integration time, like 1/10 of a second. Having spent 2 years helping build a radio telescope, I was its first user. I used it for the first 6 months, and I found about 180 more quasars. That was good. Previously, there were 20 known, so I got the number up to 200, and that's a good sample. But first, we had to build the radio telescope, and the graduate students did this with some technical assistance and some undergraduates working through the summer. My responsibility was all the cables, all the connectors, all the plugs and sockets. I'll show you a photograph of the radio telescope in a minute. A lot of the work was done outdoors. This photograph is taken in the winter in Cambridge. It was very cold. And this is me in disguise. This is Don, my assistant. We've been putting plugs and sockets on the ends of cables. And I'm using a slotted waveguide to check the impedance, to check that all the plugs and sockets have good connections. So this is the finished radio telescope. It's huge. It's an array of dipoles. So there's a bit of a dipole here and another bit here. And the signal comes down to this and then goes away a long way there into the distance and finally way into the laboratory. So there were about 2,000 of these dipoles working at a frequency of 81.5 megahertz. And it took 6 of us about 2 years to build this radio telescope. It was quite heavy work. I could swing a sledgehammer by the end of all that work. Then when it was built, at the beginning of my final year, everybody else moved on to other projects, and I was left to debug the telescope and get it working and make observations. At that time, this is 1968, the University of Cambridge had 1 computer. It had less memory than your laptop. It was the university's central computer, and very few people could get time on it. And we could not get time on it. Our data came out on these rolls of paper chart. Here, rolls of paper chart. 30 meters of this every day. I scanned the sky every 4 days, so 120 meters for each sky scan. And I did that for 6 months. So I had over 5 kilometers of this paper chart. Now, I quickly got used to identifying quasars. The other thing that radio telescopes can pick up is radio interference. Anything that sparks gives a radio signal. So arc welders, sparking thermostats. And at that time, cars were badly suppressed. So cars can sometimes give interference. And there was quite a lot of it, so you got used to identifying it. You also got used to identifying the quasars. Now, because of imposter syndrome, I was being very, very careful, very thorough, working very hard. I was quite sure they were going to discover they had made a mistake admitting me to Cambridge. But when they discovered their mistake, they would throw me out. I would have to go home, and that would be the end of my PhD. But I decided I would work my very hardest so that when they threw me out, I'd know I'd done my best. I would not have a guilty conscience. And so I was being extremely careful, extremely thorough, working very, very hard. And just occasionally on these charts, there was about 0.5 centimeter of signal that didn't look like a quasar. And I wasn't too sure what it was, but your brain actually remembers a remarkable amount, because after I'd seen this curious signal a few times, thing that I could not classify, my brain says, "You've seen something like this before, haven't you? You've seen something like this from this bit of sky, haven't you?" And then it's easy, because I can get out the charts for this bit of sky and discover that, yes, it was sometimes there. About 1/3 of the time it was there. 2/3 of the time it was not there. But when it was there, it was at the same right ascension and declination. It had the same position. We now know that this was a pulsed signal. You can't see it very well here. Sorry, here, this is it. But these are pulses, 1 1/3 seconds apart. They're all squeezed up very close on this image. We now know that those pulses came from a star we call a pulsar. It's got a very compact core. It's what's called a neutron star. It's got a radius of about 10 kilometers and a mass of about 1.5 times the mass of the sun. So it is very, very dense. It spins about an axis that is vertical, but its north and south magnetic poles are offset. And a beam apparently comes out from the North Pole and the South Pole. And as the star spins, this beam sweeps round the sky. And when it sweeps past our face, past our radio telescope, we see a flash. And it turns out that each pulsar has its own particular flash rate and pattern of flashes. So they are quite like lighthouses. Now, this was a totally unexpected discovery. And it caused great stir in astronomical circles. I believe that this imposter syndrome led to it. Imposter syndrome, the feeling that they'd made a mistake admitting me, they were going to discover their mistake and throw me out. That is imposter syndrome. And that's what made me work so very, very carefully and notice this peculiar signal. In the short term, it did not have much impact on my career, but it has helped me survive, keep in astronomy, as I will explain. I got engaged to be married between discovering pulsars numbers 2 and 3. I found the first 4. So in the middle of that, I got engaged to be married. And my friends outside academia, outside the university, were absolutely thrilled that I had got engaged. Congratulations on your engagement. But they said nothing about my having made a major astrophysical discovery. I think it was because at that time, the peak of a woman's career was getting married. Women didn't have careers outside the home. They got married, yippee, and then became stay-at-home wives, mothers, housewives. And in getting engaged, I was conforming to the pattern that women were expected to follow. Now, I wasn't so sure that that was my plan, but that was what society thought I should do. So I did get married. I got married as I finished my PhD. My husband worked in local government, and to get promotion in local government, you move to another part of the country. So every 5 or 10 years, we moved to another part of the country. And several years later, our son was born. In Britain at that time, mothers were not expected to work outside the home. Mothers were stay-at-home wives and mothers. So there weren't childminding facilities, no nurseries for the children, or very, very few. So it was really quite hard for me to work and to keep working, both because of my husband moving and because of there being a child. I don't know if you have a game that we have in Britain called Snakes and Ladders. You throw a dice, you count your way, 1, 2, 3. Oh, there's a ladder. I will go up the ladder and I get on fast. But maybe from here, I score 1 on the dice, I land on the head of a snake and I go back down here. So my career felt a bit like that. I would move with my husband to some place. I would find a job at the nearest astronomy place. I wrote a begging letter. They found a bit of money. They gave me a part-time job. I worked my way up the ladder in that place. And then my husband said, we must move. And I slide down a snake, end up in a different place, have to find another ladder, climb up that. So I did a lot of changing. I did my PhD in radio astronomy. We have the whole electromagnetic spectrum here. Here's the visible, ultraviolet, X-ray, gamma ray, infrared, millimeter radio. So I start in radio astronomy. Then because my husband moves job, I go to gamma ray astronomy. And I work for a few years in gamma ray astronomy. Then my husband changes job, so I go to X-ray astronomy. Excuse me. After a number of years in X-ray astronomy, my husband moves job, and I go to infrared, and then millimeter. And then the marriage breaks up, and I go to a new university and set up a new astrophysics group, and we work right across the spectrum. Whatever wavelength is appropriate to answer the astrophysical question we're currently researching. So I've had a lot of experience and a lot of fun, and I've been very lucky. When I came into X-ray astronomy, the subject was just lifting off. When I came into millimeter wave astronomy, it was very, very new and exciting. So I've had a lot of fun. So I've been a researcher, I've been a university lecturer, I've been a tutor, I've been a manager, a professor, a head of department, a dean, and I've done public relations and outreach. But it's never been easy being a woman and having a career in a physics-related subject. It's much, much better now, but at that time in Britain, women did not have careers. And I remember a neighbour when I just moved saying, you've got a husband, a new baby, and a new house, and you say you're bored. What's wrong with you? Now, I expect many of you, men and women, will expect to have careers. My generation in Britain has been rather at the turning point, the changeover point. So I've had a couple of postdoc positions in Southampton University doing gamma ray astronomy. I had a research fellowship and then a teaching fellowship. So I started lecturing there. We then moved and I went to Mullard Space Science Laboratory, working part-time. I was on the technical staff there as a programmer, and then they got a bit more money and made me an associate research fellow. Then my husband moved, we went to the Royal Observatory, Edinburgh. I'm still working part-time. I have a research fellowship to begin with, and then I'm managing groups of people. Then I moved to Milton Keynes, become chair of the physics department in the Open University. I have a sabbatical in Princeton University. I then take a university management job, and then I retire about 15 years ago now. So it's what you call a portfolio career. It's not the pattern that a man would have, I have to say. So what have I learned? What useful things can I pass on? Especially if you're a woman, but anybody who has to keep going without what's sometimes called a proper job. Maybe you have difficulties getting postdoc positions. So keep up your networks. Keep in touch with your professional body. Try to get a work address, a professional address, a laboratory address. Ask for a visiting position, maybe unpaid, but ask if you can be listed there and use the work address. You can do quite a lot of research plundering databanks. You can referee for journals and for research councils. You could be a journal editor or maybe an assistant or just general help. Join your professional body and maybe serve on one of its committees, or maybe a funding body or a research council has a committee you could serve on. Teach. Does your local university or even your high school need tutors? Supervise a senior project. Be an examiner for projects. Above all, recognize what transferable skills you are getting and put them on your curriculum vitae. You know, even as a stay-at-home wife, there are things you can put on your curriculum vitae. You're managing a budget, you're looking after money, you're raising a child, you're dealing with people, juniors. And if you can get your child to do what you want it to do, you can probably get your boss to do what you want them to do. So the skills you learn at home are actually transferable to work. So yeah, running a home, raising a family, you get experience of budgeting. You do a lot of multitasking, time management. You do a lot of interpersonal things, and you do a lot of planning. But I think above all, I would say, take risks. Surprise yourself. Do not be too cautious. Remember that one failure does not make a disaster. Einstein got things wrong, and look how he ended up. But you will need to be persistent. You should aim as high as you can, and try to keep your options open. Try to have several ways you could go, several different things you could do, in case some of them close off. And this is my favorite quote, addressed primarily to the women. It comes from Laurel Thatcher Ulrich, who is at Harvard University in the United States. And she says, well-behaved women rarely make history. So it's probably true for men. So don't be too well-behaved, is my message. Thank you for your interest. Thank you for your attention. Maybe there are some questions now. Thank you.